Hi everyone, Ashley here with Uncomplicate Ed. Today with Uncomplicate Ed, we're going to be uncomplicating fractions. A lot of times when I ask teachers, what are some barriers that our students have in terms of learning mathematics? Fractions always comes up. Today specifically, we're going to be talking about multiplying fractions. And even more specifically, we're going to be talking about multiplying a whole number times a fraction. So let's dive in. The problem we're going to be solving today is 5 times 2/3. In other words, a whole number times a non-unit fraction, 5 groups of 2/3. Now, a non-unit fraction meaning any fraction where the numerator is not 1. We're also iterating here. We're saying 2/3 5 times. So why does the standard algorithm work? We know we need to multiply the numerators and the denominators, but what math are we really solving? And how do I know if my answer is reasonable? A question I often heard from students is, why did my number get smaller? I thought with multiplication, it got bigger. We're going to use concrete, representational, and abstract way of thinking. That CRA method is proven to be what students need in order to understand what's really happening when we are using a standard algorithm such as this one. All right, let's see what we've got. Let's take a look at 5 times 2/3 in concrete objects. I'm going to use crayons for this. So first thing I need to do is I need to create and establish a set of what my whole is. And because I'm dividing it into thirds, right, 5 times 1/3, I'm going to say 3 isn't a set, because then I can do 1/3, 1/3, 1/3. Now what we're trying to solve is 5 times 2/3. So I need 5 sets of 2/3. So there's a set of 2/3. That's 1, 2, 3, 4, 5. Here are 5 sets, or 5 groups, of 2/3. Now I can just count up all of the thirds that I have to determine what my answer is going to be. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 thirds. Now if I were asked what is it in its simplest form, I'm going to see if I can make any whole sets. Well, I know that there's 3 in a set, so I can just do some maneuvering here. I just created a set. There's 3 in a set, and there's 3 in a set. Remember, I didn't add anything or take anything away. So I had 10 thirds. Now I have 3 whole sets and 1/3. So 5 times 2/3 equals 10 thirds, which is equivalent to 3 and 1/3. Let's show 5 times 2/3 using pattern blocks. So this would be the next level in concrete understanding. So I need to establish again, just like I did before, what is a set and what are my 1/3s. So I know my pattern blocks. If this is considered my whole, then when I divide it into thirds, I'm using these rhombi, okay? So that is an entire set. And again, the problem was 5 times 2/3, or 5 groups of 2/3. So I need 5 groups. Let me go ahead and set out 5, okay? But I only need 2/3, right? 5 groups of 2/3. So I'm going to set this up into my 5 groups of 2/3. And I like setting it up right on top for my students to really see sort of that missing piece of the third. So they know this is 2/3 and 2/3 and 2/3. So I have done 2/3 5 times. That would give me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 thirds. 5 times 2/3 is 10 thirds. Again, I can ask, what is it in its simplest form? So I'm going to see if I can make any wholes with it. Again, not by taking away or adding anything, just using the pieces I have. Can I make wholes? Well, I sure can. Again, I'm just going to maneuver some of these, or manipulate it if you can. Okay, that just made a hole. I can see I can make another hole here. I can make another hole here. I've got nothing left on here, right? Get rid of that. Or I can leave it if that helps your students see it. But now I can see I have 3 holes and 1/3. So again, 5 times 2/3 equal 10 thirds, which is equivalent in its simplest form to 3 and 1/3. The next level might be moving on to something like connecting cubes, okay? So again, 5 times 2/3. I need to be able to create a set that I can break into thirds. The easiest way to do that is to have 3 pieces, right? So I have 1/3, 1/3, 1/3, and I say all 3 make a set. No, I need 5 times 2/3, or 5 groups of 2/3. So all I'm going to do is grab 2, 5 times. The colors don't matter. Let me get rid of this whole one here. So I have 5 groups of 2/3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 thirds. Again, 5 times 2/3 is 10 thirds. I would again ask, can it be simplified into a simple form by, in other words, making any whole groups? There are 3 in a whole group, so by maneuvering some, I can create whole sets, knowing that there's 3 in a whole set. So without adding any or taking any away, 10 thirds is equivalent to 3 1/3. The same thing could be done with counters. And because it's very similar to the cubes, I'm just going to model it quickly. So again, if we want to make something that's into thirds, easiest way to do that is to have 3 pieces. Okay, so I am going to use the colors in this one again so the students can easily see 2/3 versus a whole. So I have 5 sets of 2/3. 1, 2, 3, 4, 5, which is equivalent to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 thirds. Again, I would ask, can I make this simplified without adding or taking anything away? Sure can. I'm going to start building some sets. I just made a set. I can move you up. There's a set. That up. And there's a set. And here I go. 3 1/3. The next level in building pictorial representations. Now that we've kind of got the concrete out of the way, I'm going to use graph paper. This is 1-inch graph and 1-inch grid paper. And I'm basically doing the same concept, okay? 5 times 2/3. I need to establish my first set. So I'm going to say each row, there's 3 in a row. So if I have 2/3, there's my 2/3, okay? And I can scribble it in like this. Of course, if I wasn't using a dry erase marker, I could just have this colored. I'm doing 2/3, and I'm using the dot just again so the students can see that it's making a whole third. I have 2/3 5 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 thirds. Again, I can ask, can I simplify this answer? So yeah, I sure can. I'm going to take some of these and see if I can make some whole groups. I can move this one here. Now what I do here, I've got to take away there. We can see the movement. Okay. Oh, I can see I can just move that over there. So I'm going to do that this time. Great. And I'm going to go ahead and move you over here. Fantastic. 10 thirds is equivalent to 1, 2, 3 wholes and 1 third. All right, now let's go to the least concrete way. We're actually moving to a number line. So we're moving a lot closer to really understanding what we're doing here in terms of multiplying fractions. So I'm going to go to mathlearningcenter.org/apps, and I'm going to click on number line, open in the web app. And I want to use a number line to represent multiplying fractions. Remember, we're doing 5 times 2/3. So I'm going to choose a fraction number line. I see one for fractions, and I see it already divided into thirds for me. Remember, we are doing 5 times 2/3, so I need it into thirds. I'm going to go ahead and space it out a little bit more loosely for me, and they're done. Now I need to get my jumps of 2/3, and let's make sure that's accurate. Yep. If I want to label it, I can click on it and label it as 2/3. Now remember, the problem is 5 times 2/3, so how many sets of these do I need? I need 5. I got 1. I can come down here to duplicate and just continue to duplicate until I have 5 groups. There's 1 already on the screen, 2, 3, 4, and 5. Now I'm going to manipulate them so they're end to end on the number line, making sure I have 5 groups of 2/3. So I can see 5 groups of 2/3. I could count these individually, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 thirds. Or it's actually a lot easier to see it in its most simplest form, isn't it? I can see that 2/3 5 times is 3 1/3. I hope this helped to uncomplicate the idea of multiplying fractions, specifically a whole number by a fraction, other than using the standard algorithm by multiplying the numerators and the denominators. A lot of us know that standard algorithm, and we teach it to our students, which is great. And can our students prove it using other objects and justify their thinking? Or for those students that think more concretely, maybe starting with the idea of using manipulatives will help them understand it when we get to more abstract things, such as the algorithm. Yeah, hope this helps, everyone. Have a great day.